Hello students, welcome to my channel. Today we shall be discussing on the topic binary number system. The binary number system is a JSS1 topic for the second term. We shall be discussing different outlines regarding this topic, but before we begin the topic proper, let's identify some other base numbers with respect to the names they bear. Then again, we will also look at the definition of a given number system. Right, so I say that the base of a number system refers to the total number of digits used in the given number system. For example, base 2 contains 2 digits, base 3 contains 3 unique digits. So we shall be looking at some of those digits going forward. But first of all, let's look at the base numbers and their names. Base 2, we call them binary, just like the name implies, bi. Whenever you hear anything by, it has to do with 2. It's existing in double. So base 2 are referred to as what? Binary or decimal numbers. That's the name we give to base 2 numbers. Then base 8 are called the octal numbers. Octal numbers. Then base 10 are called decimal or denary numbers. Base 16 are called hexadecimal. Get familiar with these names because we may be using them at one point in our discussion going forward. So sometimes you may be asked to convert a certain base to binary number. When you're asked to convert a certain base to a binary number, that means you are converting it to base 2. But if you don't know that binary means base 2, you may not know what to do in that case. So you need to get to know the names of these various number bases. I hope that's quite clear. Base 2, binary or decimal. Base 8, octal numbers. Base 10, decimal or denary numbers. Base 16, hexadecimal. We have various other bases. I know somebody may be asking a question, what about base 3, what about base 4, base 5, and so many others. Yes, they are very, very important base numbers, but these are the most important ones we have. You always see in your various texts in the textbooks. That's the ones you'll be seeing. But we have a base 3. Base 3, they are called the trinary. Base 4 are called quaternary, and so on. So they have their names, but the major ones are the ones I have written on the board. All right, so but at this level, we'll be discussing on binary. That is for the JSS1 student. By the time you get to JS3, you'll be talking about base 3, base 4, base 5, and other bases, switching between them. All right, so let's get back to the definition and try to get some facts about it that are very, very important in this lesson. Let's get the definition again. We said that the base of a number system refers to the total number of digits used in the given number system. Take for example base 2. When we talk about base 2, what are the digits that are contained in base 2? The digits that are contained in base 2 are 0 and 1. 0 and 1. These are the two unique digits that exist in base what? 2. That's why the definition says that the base of a number system refers to the total number of digits used in the given number system. And the total number of digits here are 2-digit numbers, which include what? 0 and 1. And one thing you need to understand here is that the highest number, the highest digit number you can find in base 2 is 1. So the high digit number you can find in any base is always 1 less than that number base. Likewise, if we talk about base 3, the highest digit numbers you can find in base 3 is what? 2. So base 3 numbers include 0, 1, and 2. These are the various digit numbers that are obtainable in base 3. How many digits do we have here? 1, 2, 3. There are 3 digits numbers. That goes with our definition. If we talk about base 4, for example, base 4, what are the digit numbers there? 0, 1, 2, 3. These are the digit numbers that are involved in base 4. So what is the highest digit number you have in base 5? I know somebody may have gotten the answer. The answer, of course, is what? 4. That is the highest digit number you can find in base 5. And what are these digits? The digits involve 0, 1, 2, 3, and 4. These are the digits that are obtainable in base 5. So you can never have 5 inside base 5. Or for somebody to write something like this, 2115, they say it's in base 5. It is absolutely wrong, because you cannot have digit 5 in base what? 5. The high digit you can find in base 5 is what? 4. The high digit you can find in base 6 is what? 5. The high digit you can find in base 7 is what? 6. The high digit you can find in base 8 is what? 7. The high digit you can find in base 9 is 8. The highest digit you can find in base 10 is what? 9. So let's take a look at that base 10. If we're talking about base 10 now, what are the digits involved? The digits involved in base 10 are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the digits involved in base 10 numbers. And base 10 numbers, I refer to them as the chief of army staff of all bases. The chief of army staff of all bases. That means they are central to other bases. Our everyday transaction, the buying and selling we do in our everyday life, are done in base what? 10. When your mother gives you money to go to the market to buy something, or your father gives you money to go to the market to buy something, the transaction you'll be making there, buying and selling you'll be doing there, is done in what? In base what? 10. That is why in your calculator, you have the numbers arranged from 0 all the way to what? 9. You have 0, 1, 2, 3, 4, all the way to 9. Because in calculator, you can never find a button where it is rating 12. One button, no. For you to get 12, you have to press your calculator, press 1 and press what? 2 for you to be able to get what? 12. So base 10 is central to other bases. That's why we can convert from base 10 to other bases, and from other bases to base what? 10. So let's get started with another outline. Hope you understand what the definition is about. That the base of a number system refers to the total number of digits used in the given number system. You can see the total number of digits existing in base 3, the total number of digits existing in base 2, total number of digits existing in what? Base 10. And the highest number of digits you can find in any base is always 1 less than that base number. I hope this is quite clear. Because in the exam, if I ask you, base 2 are represented with 2 unique digits which include dash and dash, what will be your answer? 0 and 1. These are the digits involved in base 2. Alright, so let's now move to the next outline. Let's move to the next outline. The next outline will be conversion of base numbers. So the first one we are going to look at will be converting base 10 to base 2. Converting base 10 to base 2. That is the first thing we are going to be looking at now. Alright, so converting base 10 to base 2. This is one most important fact we have to get now. When converting from base 10 to any other base, be it base 2, be it base 3, be it base 4, be it base 5, base 6, base 7, base 8, base 11, base 12, and so on, in as much as from base 10 to any other base, what we do, the method we use is successive division. Successive division, and we take note of our remainders. Let's give some examples. Example number 1, we shall be converting 12, which is in base 10, to base 2. Look at the way I wrote the base. This is how you write the base number. In some textbooks, you see it like this: 12 base 10 to be written in this form. But I prefer my students to write it this way. You write it in words rather than in figure, because some people can be careless while trying to write 12 in base 10. You see them writing something of this nature. And when you write something like this, no longer 12 in base 10. Hey, what you now have here is 1210. So you have to be very, very careful, because if you write something like this in the exam, you'll be marked wrong. You get 0 in that. So try to avoid that. Instead, you write it in this form. Alright, so let's get to the next one. Number 2, we shall be converting 38 from base 10 to base 2. And finally, we shall be converting 112 in base 10 from base 10 to what? Base 2. Let's get the solutions. Solutions number one. Solution number one. We have 12 in base 10. Remember what I said earlier on. When converting from base 10 to any other base, you divide by that number you are converting it to. So for instance, for this one now, 12, we are converting 12, which is in base 10 to base 2. So if you are converting base 10 to base 2, that means you have to be dividing everything by 2. If you are converting base 10 to base 3, that means you have to be dividing everything by 3. If you are converting base 10 to base 7, that means you have to be dividing everything by what? 7. So, but in this case now, we are converting base 10 to base 2. What do we divide by? We divide by what? 2. We use 2 to divide everything that we have here and take note of our remainders. Now look at how we do that. Remember in primary school, you were taught on how to use boxes or balls or 2 heads to divide. So 2 people dividing 12. So let's see what it will give us. Let's divide 12 between these 2 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so how many? 1, 2, 3, 4, 5, 6. So this person will get 6. 1, 2, 3, 4, 5, 6. That means it will give them 6, 6. Is there any remainder? No remainder. So in this case now, it will be remainder what? 0. Nothing remains. So how do we write it in this form? So 2 divide 12 will give us what? 6, 6. Remainder nothing. That nothing means 0. Remainder 0. I hope it's very, very clear. Good. Anybody who understands multiplication table very well, you don't need to be drawing 2 heads and be dividing. So we continue to use 2 to divide. Since you are changing to base 2, use 2 to divide all 2. 2 divide 6. Let's divide 6 between these 2 people. 1, 2, 3, 4, 5, 6. How many? To give us 3, 3, remainder nothing. So to give us 3, 3, remainder 0. There nothing will remain. So 2 will continue to divide on 2. We have 0 remainder something. All right, 2 divide again. 2 divide 3. 2 people dividing 3 ranges. 1, 2, 3. In this case now, you find out that they will have 1, 1. Remainder 1. 1 will remain. So in that case, we write 1, 1. Remainder 1. So 2 divide 1. 2 divide 1. You know, in primary school, in this case now, you say it cannot go. When we say 2 divide 1, you say it cannot go because 1 is too small for 2 people to divide it. But if you want to divide, you give it to one person. The other person will have nothing. So in this case now, 2 divide 1 cannot go. That it cannot go means you write 0. That's what you call it in primary school. So 2 divide 1, it cannot work. So what do? You write 0. Remember that number that cannot go, you bring it down here. 2 divide 1, it cannot work. So in that case, it is 0. You carry that same number that is here and bring it here. Okay, so that is how to go about it. And that's the end of that particular one. You draw an arrow pointing upward. What it means is that you start writing your answer from bottom to the top. You don't start from top to the bottom. Rather, you write your answer from bottom to the top. So the answer to this question will now be 1100. 1100 in base what? In base 2. So this is the answer to this question. I hope this is quite clear. Good. So pause the video and try number 2. Pause the video and quickly try number 2 to see whether if you can get the answer correct. I believe you have done that already. Let's go to that. Number 2. Get the solution to that. Question number 2. Question number 2, which is 38. Base 10, we are changing it to base 2. 38. Since we are changing to base 2, we have to divide it by 2. 2 divided 38 will give us 19. Remainder nothing. Nothing will remain. Okay, 2 divide 19. If you use the same method of using 2 heads to divide, 2 divide 19, that will give us 9. Remainder 1. 1 will remain this time. Then 2 divide 9 will give us 4. Remainder 1. Then 2 divide 4. 2 divide 4 will give us 2. Remainder nothing. Nothing will remain in this case now. Then 2 people dividing 2. 2 people dividing to 1, 2. It will read them 1. Nothing will remain. So that will be 1. Remainder 0. So 2 divide 1. 2 divide 1. Remember, in this case now, we normally say it cannot go. That means 0. Remainder. That's same 1. So you point an arrow upward. meaning that your answer will not be 100110. 100,110 in base what? 2. Don't forget to write the unit base 2. So this is the answer to this very question. I hope that is quite clear. So let's go to the last one. You can also give the last one a try. Let's do it quickly. Question number 3. Question number 3. 112 in base 10. We are changing it to base 2. That means we have to use 2 to divide all through. 2 divide 112. What will it give us? That will give us 56. Remainder nothing. So 0 will remain in this instance. Then we can still use 2 to divide again. 2 divide 56 will give us 28. Remainder nothing. 0 will remain. 2 divide 28 will give us 14. Remainder nothing. Then 2 divide 14 will give us 7. Remainder what? Nothing. Then 2 divide 7 will give us what? That will give us 3. Remainder 1. 2 divide 3 will give us 1. Remainder 1. Then 2 divide 1. Remember, it cannot work here. So you write 0. Remainder what? 1. You put an arrow like this, indicating you start writing from bottom to the top. So 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0 into 4, 0, 0, 0. In base what? In base 2. So this is the answer to this particular one. I hope it's very, very clear. Good. So we now move to another outline. Good. Let's move to the next outline. This time around, we'll be converting from base 2 to base 10. We're going to do the reverse of what we did now. We'll do the reverse of it. So converting base 2 to base 10. To base 10. That's what we'll be doing. So what are the questions, examples that we have there? Example number 1. We shall be converting 1100, which is in base 2. We change it to base 10. Then again, number 2, we have 11011 base 2. We convert it to base 10. Then finally, we have 11.11, which is in base 2. We convert it to base 10. So these are some of the examples that we'll be giving now. All right, so let's get started. Solutions. How do we approach this very one? What we do in this instance is that this time around we are converting from base 2 to base 10. Remember, when you are converting from base 10 to any other base, be it base 2, base 3, and so on, you do division. But when it is from other base to base 10, you are going to do successive multiplication. So converting base 2 back to base 10, we do successive multiplication. So that is the reverse of the method we used previously. When it is base 10 to base 2, you do division. If it is base 2 or any other base to base 10, you do a successive multiplication. Let's get started with number 1. Number 1 will have 1100, which is in base 2. Let's see how it goes. Good. Whenever you have a number in a certain base to be converted to base 10, the first thing you do is to identify the powers in which the base will be raised to. You identify the powers in which, like now, if you have 2 raised to power, so this number is called the power. So we're going to be identifying the powers in which these bases, the base numbers will be raised to. So for us to do that, whenever you get a question like this, what you do is that you start from the right, the last digit from the right, and number it all the way to the left. You start numbering from 0 all the way to the left. So I will start from here now and say 0, 1, 2, 3. That's how you number it. If I have another one now, I continue 4, 5, and so on. But the number stopped here, so that's why I have to stop there. I hope the arrangement is quite clear. You start from whichever number you have here. You start with 0, 1, 2, 3. If you have another one, you continue in that order. All right, so that's how to make the arrangement of identifying the powers that the number will be raised to. Now, we'll be picking them one by one. We'll pick the first one. This is 1. So the way we are going to do it will be in this form. We'll pick the digit here now, 1, right? 1 times the number base 2. If what you have here is base 3, that means we'll be turning it to 3. But since what we are dealing with is base 2, we'll pick this one, say 1 times 2 raised to power what? 3, the one that is on top. So that will now be 3 like this. This is how we write it. Plus, we go to the next one. That is 1 times 2, because it's in base 2 we are talking about. Raised to power what? 2. Plus, we go to the next one. The next one is 0. So write that 0 times 2 raised to power what? 1. Plus the last one, which is still 0. So 0 times 2 raised to power what? 0. I hope the arrangement is quite clear. So looking at it once again, 1 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 0 times 2 raised to power 0. Okay, so that's how the arrangements are made. I hope it's very, very clear. Okay, so now let's resolve the brackets. So we have it as 1 times 2 raised to power 3 will give us what? I know somebody will say 6. No, 6 is not the answer. 2 raised to power 3 is not 6. 2 raised to power 3 is an index form, which means 2 times 2 times 2. So 2 times 2, 4. 4 times 2, 8. So 2 raised to power 3 will be what? 8. What this means is that 2 times itself into 3 places. That's what we have here. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. So 2 raised to power 3 will give us what? 8. Hope is understandable. Then plus, we go to the next one. 1 times 2 raised to power 2 will give us what? 4. Okay. Plus, we'll go to the next one. 0 times 2 raised to power 1 will still give us 2, because anything raised to power 1 will still give you the same number. Plus 0 times 2 raised to power 0. This one is very, very important. Anything, according to the law of indices, anything raised to power 0, the answer is 1. Anything in mathematics raised to power 0, the answer is always what? 1. 1 million raised to power 0, the answer is 1. 10 raised to power 0, the answer is 1. 9 raised to power 0, the answer is 1. You can say 503 raised to power 0, the answer is what? 1. Anything raised to power 0, the answer is always what? 1 in mathematics. I hope that is clear. Good. So how do we write this one now? We have 2 raised to power 0. What will it be? 1. So we can now multiply out the brackets. 1 times 8, that will give us 8. Plus 1 times 4, that will give us 4. 0 times 2, that will give us 0. Plus 0 times 1, that will give us 0. So the final answer will now be 8 plus 4. That will give us 12. 12 plus 0 plus 0, that will still give us what? 12. In base what? 10. Good. Wonderful. So this is how to go about this solution. I believe you can give number 2 a try. Give it a try and see whether you'll be able to get the answer. Pause the video and give it a try. All right, so let's do it together. All right, number two question says 11011 base 2. Remember how we number it. You start from the last number by the right to number it from 0, 1, 2, 3, 4. You can see how it goes. That's how you number it, to know the powers in which these numbers will be raised. So let's start with the first one, the first digit 1. So it's going to be 1 times 2 raised to power 4 plus 1 times 2 raised to power 3 plus 0 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. That's how you arrange it. So let's do it now. 1 times 2 raised to power 4. We are done with the first one. The second one plus 1 times 2 raised to power 3 plus, go to the next one, 0. 0 times 2 raised to power 2 plus the next one, which is 1 times 2 raised to power 1, plus the last one, which is 1 times 2 raised to power 0. Alright, so let's now dissolve it further. That will give us 1 times 2 raised to power 4. 2 raised to power 4. What will it give us? That's 2 times 2 times 2 times 2. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So 2 raised to power 4 will give us what? 16. Plus 1 times 2 raised to power 3 will give us what? 8. Because it will mean 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. Plus 0 times 2 raised to power 2 will give us 4. Plus 1 times 2 raised to power 1 will still give us the same thing. Or 2 raised to power 1. That will still give you 1, 2. So that will give us 2. Plus 1 times 2 raised to power 0. Can you remember? Is equal to 1. Because we say that anything raised to power 0 is equal to 1. 1 times 16. That will give us 16. Plus 1 times 8. That will give us 8. 0 times 4. That will give us 0. 1 times 2. That will give us 2. 1 times 1, that will give us 1. 16 plus 8 will give us 24. 24 plus 2, that will give us 26. 26 plus 1 will give us 27 in base what? 10. And that becomes the answer to this particular question. I hope this is very, very clear to everyone. Good. Good. Now, let's go to the last one. Let's go to the last one. The last question of the day. Let's quickly move to that. The last question of the day. Question number 3. Question number 3 says 11.11. This time around we have point. How do we approach this? Pay absolute attention. When you look at a number like 3.5, for example, 3.5, this number is made up of 2 parts. It's made up of 2 parts. The digit you have before point is called the whole number. This is 3 whole number. So after the point, the one you have is called decimal, while this one is the whole number. This is the whole number, this is decimal. So for this particular question we have on the board, the 1 you have before the point is known as what? The whole number part of it. So this 1 is the whole number part of it. If I close my eyes on this one, it will look naturally like this one, because this one there is no point. So the way I treated this one, that's how I'm going to treat this one that appear to be a whole number form. So that means I have to arrange it like this: 0, 1. That's the one that is a whole number. Okay? It looks quite like this one. Then after the point, the ones you have there after the point, the first one will be minus 1. The second one will be minus 2. So after point, you will now be having minus 1, minus 2, minus 3, depending on the number of digits you have. So, but for the one before the bracket, we arrange it the same way we do this one. Start from the last one from the right, that's 0, 1. If we have another one, now 2, and so on. So that's how to do the arrangement. Good. So now let's do the to spell out the solution, just like the way we did number 1. That's how we are going to do it. Same method we use in number 1. That's still the same method we are going to use for this particular one. So let's pick them one by one. So it's now going to be 1 times 2 raised to power 1 plus 1 times 2 raised to power 0 plus 1 times 2 raised to power minus 1 plus 1 times 2 raised to power minus 2. That's how we are going to arrange it. Let's start now. The first one, 1 times 2 raised to power 1 plus, go to the next one, 1 times 2 raised to power 0 plus, we go to the next one, 1 times 2 raised to power minus 1 plus the last one, 1 times 2 raised to power minus 2. I hope this is very clear. There is something I want us to know before we begin to answer this question proper. Let's just pause for this one and pay attention on what I'm going to do. There's a law of indices which says that if you have x raised to power minus a, for example, this is what we call the negative index law of indices, or negative power law of indices. Though you'll be doing it in JS2, but I want to use it to explain what we are going to do with these two things that we have here. So whenever you have anything raised to power a negative number, so what it means is that according to the law of indices, this minus you have here, this minus alone you have here, means 1 over. That's what this minus means. Okay, so we are done with this minus now. Then you can now carry these other ones and write at denominator. That will now be x to the power a. That's how to transform this number to look like this. The minus you have means 1 over. Then you now write the remaining ones. So if you have something like this, for example, 5 raised to power minus 2. 5 raised to power minus 2. How do we write this one? Remember what I said, this minus means 1 over. Then you now write the remaining one, which is 5 raised to power 2, which will eventually give us 1 over. 5 raised to power 2 means 5 times 5, which will give us what? 25. I hope this is clear, because we are going to apply it in the question that we're going to solve here. I wouldn't want you to get confused on this. Let me give you another one so that you get to do it yourself. Do this one you're off quickly. Pause the video and do what I will show you now. If you have 2 raised to power minus 3, pause the video and do it and see whether if you get the answer. All right, so that will give us this minus. Remember what I said, this minus means 1 over. Then we'll now write the remaining one, which is 2 raised to power 3, which will now mean 1 over. 2 raised to power 3 means 2 times 2 times 2, which will give us what? 8. So that is how we write this kind of a thing. I hope it's clear enough, because we are going to see it in our solving. Now let's go back to our question. Let's go back to it. That will be 1 times 2 raised to power 1 is what? 2, plus 1 times 2 raised to power 0. Anything raised to power 0 is equal to 1. Hope you can still remember that. 1 times. So how do we write this? We have 2 raised to power minus 1. It's just like what I just showed you. How do you write it? It means, this minus means 1 over. Then we'll now write the other one, 2 to the power 1. I hope it's clear. So that's what I'm going to write here. That is a 1 over. In place of this one now, 2 raised to power 1 plus, then the last one, 1 times. The last one we have, what we have there is 2 raised to power minus 2. So how do we write this one? This minus means 1 over. Then we'll now have 2 raised to power 2. 2 raised to power 2. Okay, so that's exactly what we're going to write here. So that will now be 1 over 2 raised to power 2. Good. Now let's move further. Hope it's becoming much clearer. Good. So let's go further with the bracket. 1 times 2 plus 1 times 1 plus 1 times 1 over 2 raised to power 1 is still the same thing as 2 plus 1 times 1 over 2 raised to power 2 is what? 4. I hope this is clear. Now we can clear the brackets. 1 times 2 will give us 2 plus 1 times 1 will give us 1 plus 1 times 1 over 2 will give us 1 over 2, because anything times 1 will give you the same thing, plus 1 times 1 over 4 will give us 1 over 4. Then we'll be concluding it here. So 2, let's add the whole numbers. 2 plus 1 will give us 3. Okay, then the fraction. This one is a fraction we have here. So we are going to solve it as a fraction, simplify it as a fraction. So what's the LCM of 2 and 4? The LCM of 2 and 4 is what? 4. 4 divided by 2. 2. 2 times 1, 2. Plus 4 divided by 4. 1. 1 times 1 will give us what? 1. So the answer to this question will now be 3 whole number. 2 plus 1 will give us 3 over 4. That is the answer to this question. This is the answer to the question. I hope this is very, very clear to you. Good. Maybe you can rewind the video and watch it once again to understand it better. All right, so now I will now give you assignments. This is the end of our lesson for today. Then this is the assignment you have to do. Copy this in your rough notebook and do the assignment equally in your rough notebook. Don't do it in your main mathematics notebook. So let's get the assignment. So the assignment we have, So assignment number 1, convert 58, which is in base 10, to base 2. Number 2, convert 111011 base 2 to base 10. Then finally convert 1 0.11 base 2 to base 10. So these are the questions you have to solve as your assignment. Have a wonderful day ahead. Bye.